Let's look at one more example of a rationalizing substitution. Here we want to integrate x to the 1/2 over 1 plus x to the 1/3. So remember, 1/2 is a square root and this 1/3 is a cubed root. So we've actually got multiple roots in there. So when this happens, what you want to do is you want to let your u equal x to the 1 over the LCD. So it's least common denominator between 1/2 and 1/3 is a 1/6. So this would be x to the 1/6. So that's your LCD is 6. And then we need to do a dx here. So if u is x to the 6th, take both sides to the 6th power, u to the 6th is equal to x. And then that means then that 6u to the 5th du is going to equal dx, taking the differential there. So now we can go ahead and change the integral over here. So we've got x to the 1/2. Our x is u to the 6th. So that's going to be u to the 6th to the 1/2. In the denominator, we've got 1 plus x is u to the 6th. Give that a 1/3 power. And then our dx, 6u to the 5th du. So power to a power, you multiply. 1/2 of 6 is 3. So u cubed in the numerator. In the denominator, 1 plus power to a power again, multiply. 1/3 of 6 is 2, so u squared. And then we've got times 6u to the 5th du. And so this will be the 6 we can pull out in front. Integral u to the 5th times u cubed, u to the 8th. And then we're dividing by 1 plus u squared du. So notice the power on top is bigger than the power on the bottom. So we need to long divide. So we're going to do u squared plus 1 into u to the 8th. Now notice here that the powers differ by 2. So when we put in our placeholder terms there, we'll have a 0 u to the 6th plus a 0 u to the 4th plus a 0 u squared plus 1. So we divide our leading coefficients. So u to the 8th divided by u squared is u to the 6th. So we'll put that here. Multiply out in front. So u to the 6th times u squared, u to the 8th. U to the 6th times 1, u to the 6th. And we are subtracting. So to subtract, we change the signs and add. These guys cancel, so negative u to the 6th. And go ahead and bring down our 0 u to the 4th. So divide our leading coefficients again. So negative u to the 6th divided by u squared is negative u to the 4th. And that goes up here. And then multiply out front. Put it underneath and subtract. So negative u to the 4th times u squared, negative u to the 6th, negative u to the 4th times 1 minus u to the 4th. And we are subtracting. So we will change the signs and add. These cancel. We've got u to the 4th. And now we divide leading coefficients again. U to the 4th divided by u squared is u squared. U squared times u squared, u to the 4th. U squared times 1, u squared. We need to bring down the 0 u squared. And we are subtracting. So we will change the signs and add. Minus, minus. A little bit more room there. And addition. Those guys cancel. Minus u squared. And then minus u squared. Divide by u squared. Leading coefficients again. -1. So minus 1. -1 times what's out in front. We'll go ahead and bring down that +1. -1 times u squared, negative u squared. -1 times 1, -1. We are subtracting, so change the signs and add. These guys cancel. We've got a remainder 2. So this will be plus 2 over divisor, u squared plus 1. So we are integrating here, 6. And then here we're going to do quotient and then remainder over divisor. So u to the 6th minus u to the 4th plus u squared minus 1 plus 2 over u squared plus 1 du. So power rule here. So I got that 6 out in front. And then antiderivative of u to the 6th will just be u to the 7th over 7 minus antiderivative of u to the 4th, u to the 5th over 5, just power rule here, plus u cubed over 3 minus antiderivative 1 is u. And then there will be a plus 2, and antiderivative 1 over u squared plus 1 is inverse tan. So inverse tan of u, and plus our constant. And then we just need to plug back in our u, which is x to the 1/6, and we've got it. So we got a 6 here. X to the 1/6 to the 7, so that's power to a power, so you multiply. So that'll be x to the 7/6 over 7 minus x to the 1/6 to the 5th. So that'll be x to the 5/6 over 5 plus x to the 1/6 cubed. So that'd be 3/6, which is 1/2. So x to the 1/2 over 3 minus u here is x to the 1/6, and then plus 2 inverse tan of x to the 1/6. And plus constant. And we've got it. So again, we really didn't need to do any undetermined coefficients or equating like coefficients. We just needed that long division, which is the first step of partial fractions. So sometimes that happens, very often that happens when you're doing these rationalizing substitutions.